Hello students, welcome back. How are you? I hope you're all healthy, wealthy and fine. Yes, my dear students. Now, we are studying this chapter. The name of the chapter is probability, and we have gone through the basic concept of probability, that what probability is, what is the meaning of probability in daily life, and how can we solve the question. So, what is the empirical formula of the probability, that we have also studied. Now, I have left you with a question. The question was 50 seats were selected at random from each of 5 bags of seats, and we have drawn some beautiful bags over there also. Not beautiful, but yes, we have drawn. Okay, and were kept under standardized conditions favorable to germination after 20 days. Okay, after 20 days, what happened? The number of seeds which had germinated in each collection were counted and recorded as follows. So you are basically given with this table. Okay, and here's the table that is given with the number of bags. So, first number bag is here, second number bag is here, third is here, fourth is here and fifth is here, right? Okay. Now, number of seats in each bags are 40, 48, 42, 39 and 41. Okay. Now, the first question, what is the probability of germination of more than 40 seeds in a bag? Now, I have told you about how to write the question. Okay, so you can go with the language part, by or on, right? Okay, now the first one is more than 40 seeds in a bag. What is the probability of getting more than 40 seeds in a bag? Okay, so first what we have to do, mark the bags they are getting which are having more than 40 seats, more than 40 seats, not 40 seats, but more than 40 seats. So, in the first bag, it is 40, but not more than 40. 40 is 40, 40 is equal to 40, not more than 40. So, not this, then 48. Yes, this comes in this. Now, 42, yes. 39 is surely less than 40. Okay, 41 is surely more than 41. Sorry, 40. So, here we are having 1, 2 and 3 bags. In total, we are having 3 bags that are containing more than 40 seeds. Okay. So, number of bags for the first probability will be for the first PE, that is probability of getting that event done, okay, will be equals to number of bags containing more than 40 seeds. What 40 seeds? They are like germinated 40 seeds upon total number of bags. So, this is how we will be getting these 3, 1, 2, 3, 3. Okay, and here total number of bags you are getting 1, 2, 3, 4 and 5. So, 5, 3 out of 5. Okay, now how can you make it? It will be 6 by 10, or you can call it 0.6. There is 0.6 probability. There is 0.6 probability of getting a bag who's having more than 40 seeds that have been germinated. Understood? Now, the next question, next part of this question, 49 seeds in a bag. 49 seeds in a bag. Is this having 49 seeds? No. Is this having? No. Bag number 3? No. Bag number 4? No. Bag number 5? No. None. Okay. No any bag is having. So, when there is no chance we are seeing of getting an event done, okay, that means there is no probability of it. Okay. If sure it's having no any kind of probability here of having 49 seeds in the bag. How can it be possible? So, there is no possibility, there is no probability. In that case, what we are getting in our answer is a 0. So here we are getting a 0, and having a 0 as answer of your probability, that means this event is not going to be happen in that particular question, okay, according to what have been given to us. So okay, we are getting the same here for the second one. Okay, number of bags containing 49 germinated seeds divided by total number of bags. Okay, then you'll be getting it like that is 0 and that is 5. So you'll be getting 0. Then your answer will be 0. So one thing we have observed here, that our probability can be a 0 also. Okay, sure. So this is somehow the minimum value of probability, because no value you can get that can be, you know, less than the 0. So 0, obviously for sure the 0 is the minimum value for any probability, right? Now for getting the range, we have to also find out the maximum, and in this question you're getting it, you're going to get it. Okay, so the third question, more than 35 seeds in a bag. How many bags are there? Then you can see more than 35 seeds are going to be there in the bag. In this first one, yes it is. Second one, yes it is. Third one, yes it is. Fourth one, yes it is. Fifth one, yes it is. That means all five out of 5 bags are having more than 35 germinated seeds in them. So whether you are going to pick first or second or third or fourth or fifth, whichever you wanted to pick, just pick one. You are definitely going to get more than 35 germinated seeds in it. Okay, so we are going to write it like PE. And what is the probability of event? That event is having more than 35 seeds in that bag. Okay, so the PE will be, probability of getting that event will be equals to, first, number of bags having more than 35 germinated seeds upon total number of bags. This is going to be the same, the denominator. Okay, so first here getting number of them are 5, all the 5 bags, total number is also 5. So when you're getting it all out of all, that means you're getting a 1, and that is the maximum value for the probability. That means the minimum probability was 0, the maximum probability value was 1. That means the range of probability will be from 0 to 1. What does that mean? This is not in the question. The question has been completed here. What you observed from this question, students, basically that the probability of an event, okay, can be 0, can be 1, or can be in between 0 and 1. The value of probability can only vary from 0 to 1, 0 and 1 included. Okay, before 0 if you are having some value, or after 1 you are having some value on number line, so that is not going to help you. You're going to have the value of probability is in between 0 and 1. And whenever someone calls that you are having let's suppose 10% probability, now you will be saying that ma'am, this 10% probability, how can it happen? This 10 is nowhere between 0 and 1. Okay, let me be very clear about it, that if someone saying to you that 10% probability is there, he or she is not wrong. He is saying 10%. 10%, that means 0.1 probability. So the figure of speech may be differ, but the value is 0.1 here. 10% doesn't mean 10, 10% means 0.1. Okay, so this will work now. Okay, understood this question, understood the range of probability concept. Okay, now the first questions here. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. Now first tell me something, first let me tell you something about this word did not. If you're having something like that, if you're given with some things like she's hitting the boundary 6 times out of something, and the asking the probability, the event which has been asked to you is about did not hit the boundary, that means opposite is asked to you. In the case where opposite is asked to you, opposite probability is asked to you, you have to be a little more concerned about it, what is being asked to you. If the probability of this boundary 6 times hit the boundary 6 times is asked, no. When she did not hit the boundary, that thing has been asked. So there should be some alterations, right? And what will be these alterations, we are going to find out. So here's the solution to that. So what is important word in that? That she did not. Okay. Now, what is given to you? Total number of balls played is equals to 30. Right? And number of balls on which boundary was hit is equals to 6, right? Okay, now to find, I'm not going to write to find here. Now PE, the probability of getting that event done, right? That will be equals to did not hit the boundary. So total number of balls she did not hit the boundary upon total number of balls thrown. Now this is simply total number of balls thrown, this is simply 30, right? 30, okay. So here it is 30. Now if we talk about total number of balls she did not hit the boundary, she hit the boundary 6 times out of 30 balls. So the remaining balls will be definitely 30 minus 6, and that is going to be 24 by 30. Now cut it by 3, right? So 1 and 0. So that's going to be 0.8. Probability was 0.8. Any confusion about it? I hope it's very clear to you guys now, right? This is how it's done. Now, the next one. You're having here 3 coins are tossed simultaneously 200 times. How many times? 200 times. Okay. With the following frequency of different outcomes. Here are the outcomes. What are the outcomes? 3 coins simultaneously. That means you're having 3 coins and you're tossing it simultaneously. Okay, 3 at once. Okay, now frequency of getting 3 hats is 23, 2 hats is 72, 1 hat is 77, and getting no hat, that means all the tails, that is 28. Okay, if the 3 coins are simultaneously tossed again, compute the probability of 2 hats coming up. Okay, now there are 2 different things, getting all the hats or getting 2 hats. So you should be more specific about this word, because you are having 3 hats here also and 2 hats here also. So you may confuse it with whether we have to consider the 3 hats because it's also containing 2 hats. Okay, so here it's asking only about 2 hats, and 2 hats is about clearly this section. Okay, that is this section we are talking about, 2 hats. Okay, so we will be concentrating on that one also. So here if we call for the solution, probability of that event to happen will be equals to what? Number of times coins were tossed that is the denominator, the total number of trial. Okay, that is going to be for sure 200. Now, what is been asked, that probability of 2 hats coming up, number of event when 2 hats came up. Okay, so that is going to be 72, and this is here going to be what? 200. Okay, 72 and 200 out of 200. Now you can solve it further. 3 2s are 6, 1, 6 upon 100. So that can be 0.36. 0.36 will be your answer. Okay. So now it's clear to you how you'll be getting the questions of probability, and this is going to be so very simple, right? Now, have that next question for tomorrow or the next session. And the organization selected 2400 families. How many families it has been selected? 2400 families at random, and surveyed them to determine a relationship between income level and the number of vehicles in a family. The information gathered is listed in the table below. So here you're provided with the table. Okay, less than 7,000, 7,000 to 10,000, 10,000 to 13,000, 13,000 to 16,000, 16,000 or more, and vehicles per family. Okay, so this is going to be 0, 1, 2 and above 2. So they are going to be the number of vehicles. Okay. Now, it has been asked to you, if suppose a family is chosen, find the probability that family is chosen. Okay, so one of the family is chosen. Now you have to tell earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. Okay, so you have to mix these 2 data up. You are going to check for this exactly how many vehicles they are owning, first thing, and exactly how much they are earning, what is their earning range. So okay, so these 2 things will be marking in your table, okay, which is right there, and then after that you are going to divide it with the total and you'll be getting the probability. So this is going to be something thoughtful. You're going to see the table, you're going to go the question again and find out what's asking and do some your mind exercise. Okay, and we'll be get back soon in next lecture and doing the same question. Okay, so have a little good exercise of your brain and we'll be meeting in our next section with this question and many more questions. Okay, take good care of yourself, students. Bye bye. Take care.